Ever wish you could like have all the knowledge of a world-class expert instantly available on your phone?
Well,
That's kind of what we're talking about today with
yeah.
these efficient text embedding models.
Yeah.
They're like the key to making AI assistants and search engines way faster and smarter.
That's like we figured out we don't need a giant supercomputer for every task.
Right.
Sometimes like a really nimble, specialized tool is all you need.
Exactly. And that's what's so exciting about these new models like Jasper and Stella.
Yeah.
But before we like dive into those,
Yeah.
let's take a step back.
Okay.
Imagine you're in a library
Okay.
and every book has been turned into like a code
Okay.
that tells you exactly what it's about.
Hmm.
The genre, the themes, the main ideas.
Okay.
That code is kind of like a text embedding.
It's a fantastic analogy.
Right.
Yeah, these embeddings let computers understand the meaning of text,
Right.
which opens up all sorts of possibilities.
But here's the catch.
Oh.
The really powerful embedding models
Yeah.
can be huge and resource intensive.
Right.
It would be like trying to run a supercomputer on your phone.
Yeah.
Not very practical.
No, it's like having this giant truck
Right.
that gets amazing gas mileage, but is impossible to park.
Yeah.
What we really need is a sports car, something powerful and efficient.
Right.
And that's what researchers are creating with these new distilled models.
Okay, so how do they actually make these smaller, more efficient models without sacrificing accuracy?
Well,
That sounds like some serious AI magic.
one of the key techniques is called knowledge distillation.
Okay.
It's like training a student to think like an expert.
So instead of just memorizing facts,
Right.
the student is learning the reasoning process.
Precisely. And we do this by training a smaller student model
Right.
to mimic the behavior of a larger, more complex teacher model.
But how does the student actually learn from the teacher? Is it like watching videos or reading textbooks?
It's more like having a coach
Okay.
who guides the student toward the desired outcome. We use special functions.
Oh,
Think of them as like feedback mechanisms
right.
to make sure the student's understanding aligns with the experts.
So it's about aligning their understanding of language.
Exactly.
Making sure they both see the meaning of text in the same way.
Yeah. And the amazing thing is, we don't need labeled data for this.
Oh, wow.
The models can learn from massive amounts of text without any manual categorization.
That's incredible.
Yeah.
It's like learning a language by just being immersed in conversation.
Right.
But we've talked about making these models smaller and more efficient.
Yeah.
How do they actually shrink them down without losing important information?
That's where dimension reduction comes in.
Okay.
Imagine you have a detailed map of a city,
Okay.
and you want to create a simpler version that only shows the major landmarks.
Right.
You're getting rid of unnecessary detail while keeping the most important information.
So it's like creating a more concise version without sacrificing the core meaning.
We add special layers to the model that act like compressors,
Okay.
shrinking those high-dimensional vectors down to something more manageable.
It's like taking a complex multi-page document and condensing it down to a clear one-page summary.
Right.
But this whole idea of a model learning from itself, self-distillation,
Yeah,
that's blowing my mind.
it's a fascinating area.
Is that even possible?
It is.
Ah.
Imagine a model that can use its own outputs as targets for further learning,
Okay.
constantly refining and optimizing itself.
So it's like the model is constantly learning and improving on its own.
Yeah.
That's amazing. We've covered a lot of ground already.
Yeah.
Knowledge distillation, dimension reduction,
Yeah.
even self-distillation.
Yeah.
We're just getting started. In the next part of our deep dive,
Right.
we'll explore how these techniques come together in the Jasper model.
What's fascinating about Jasper
Okay.
is that it's a multimodal model.
Okay.
It doesn't just understand text.
Uh-huh.
It can also process images.
So it's like a model that can both read and see.
Exactly.
Now that's what I call a deep dive.
Yeah. Welcome back to our deep dive into the world of efficient text embedding models.
Yeah.
We left off talking about Jasper's multimodal capabilities.
Right. Its ability to understand not just text,
Right.
but images too.
But images too.
So how does a model like
Yeah.
learn to see
That's a great
in
question.
the same way it learns to read?
Yeah.
Those seem like totally different skills.
They are different, but the principles behind them
Okay.
are surprisingly similar.
Okay.
Remember how we talked about knowledge distillation?
Yes. Training a student to learn from an expert.
Training a student to learn from an expert.
Right.
So is the student, in this case, the part of the Jasper model that handles images?
Right. But where does the expert knowledge come from?
That's where things get really clever.
Okay.
We use image caption data.
Okay.
which is a huge collection of images,
Right.
each with a detailed description of what's happening in the picture.
So the captions act like the teacher,
Exactly.
providing the visual knowledge
Like a guidebook
to the student model.
for understanding what's in each image.
Okay.
Exactly. The visual encoder processes the image,
Okay.
while the text encoder handles the caption.
Right.
And just like with text,
Okay.
we use those same loss functions,
Okay.
cosine, similarity, and triplet loss,
Okay.
to align the two.
So the goal is to make sure the image and the caption
That's right.
end up with similar vectors in that embedding space.
Exact.
If the model can do that,
Yeah.
then it truly understands the relationship
That's right.
between what it sees and what it reads.
It's like learning to match a picture with its description.
Right.
Once the model can do that reliably,
Okay.
it has a powerful foundation for understanding visual content.
This is amazing. We're talking about models that can, like, see the world in a meaningful way.
Yeah.
What kind of possibilities does that open up?
The possibilities are practically endless.
Like what?
Imagine searching for images, not just by keywords,
Okay.
but by the actual content.
Right.
You could ask your AI assistant to find a photo of a dog playing fetch on a sunny beach,
Yeah.
and it would actually understand what you mean.
That would change everything about how we search for and interact with images.
Exactly.
What about, like, analyzing visual content in new ways?
Oh, yeah.
Imagine models that can, like, understand emotions in photos or identify patterns in medical images.
Yeah, and let's not forget about the creative potential.
Right.
Models that understand both images and text
Yeah.
could generate new forms of art
Wow.
or design personalized visuals based on your preferences.
This is incredible. We've gone from models that can just, like, read to models that can see
Yeah.
and even create.
Yeah, it's amazing.
But let's bring it back down to earth for a second.
Okay.
How well do these distilled models actually perform?
Right.
Can they really keep up with the big, bulky ones?
That's what's so exciting.
Okay.
Jasper and Stella have been tested on the MTEB benchmark.
Okay.
It's like the Olympics for text embedding models.
Right.
And they're performing incredibly well.
So they're not just smaller and faster,
Right.
but they're also holding their own
Yeah.
against the top models out there.
Against the state of the art.
That's huge.
Jasper in particular has achieved some remarkable results.
Really?
It's scoring higher than models with far more parameters,
Wow.
which means that distillation process
Yeah.
is working really well.
This is great news for anyone who wants to use these models
Include.
in real-world applications.
Yeah.
We're talking quicker responses from AI assistants, more accurate search results,
Yeah.
and the ability to run these powerful models on devices like smartphones.
Exactly.
The possibilities are really exciting.
And this is just the beginning.
Right.
The field is moving incredibly fast.
Yeah.
And we're only just scratching the surface of what's possible with these efficient text embedding models.
So what's next for this research?
Are there any challenges or mysteries that still need to be solved?
There are always challenges, and that's what keeps things interesting.
Right.
One puzzle that researchers are working on
Yep.
is something called the MS-ARCO inconsistency.
MS-ARCO inconsistency.
Yeah.
What's that all about?
Well, MS-ARCO is a benchmark dataset
Okay.
used to evaluate information retrieval systems.
Okay.
And Jasper is showing some unusual behavior on this benchmark.
Okay. What kind of unusual behavior?
It's really good at ranking the top results,
Okay.
but has trouble finding all the relevant ones.
So it's like it can quickly spot
Exactly.
the most relevant document,
Yeah.
but then gets lost
Yeah. Kind of loses the trail.
when trying to find other relevant information.
Yeah. It's a bit of a mystery.
That's strange.
It is.
It makes you wonder, what's going on inside the model?
Yeah. What's happening under the hood?
Any ideas why this might be happening?
Researchers are still trying to figure that out.
It could be something about the training process or limitation of the visual encoding techniques.
Right.
It's a fascinating area for further research.
So every breakthrough seems to lead to a whole new set of questions and challenges.
Yeah, that's the nature of science, I
Yep.
guess.
That's the beauty of science, I guess.
Absolutely. And this constant cycle of discovery
Yeah.
is what drives innovation
Yeah.
and pushes the boundaries of what's possible.
Speaking of pushing boundaries,
Yeah,
we've been talking a lot about how these models are trained.
right.
But let's shift gears for a moment
Right.
and think about the bigger picture.
Okay.
What are the implications of these efficient models for the future of AI?
That's a really important question.
Right.
If we can create models that are both powerful and efficient,
Right.
What does that mean for how we interact with technology
Right.
and with each other?
These are big questions
Yeah, our big question.
that we'll need to keep exploring as
Yeah,
these technologies evolve.
absolutely.
Well, one thing is clear.
Yeah.
We're entering a new era in AI
Right.
where intelligent systems are becoming more accessible and more integrated into our lives.
And who knows? Maybe the insights we gain from these models
Yeah.
will not only revolutionize technology,
Right.
but also deepen our understanding of our own intelligence.
We've covered a lot of ground in this deep dive.
We have.
From the basics of text embedding models
Yeah.
to the cutting-edge techniques being used to create smaller, faster,
Yeah.
and even multimodal versions.
It's incredible.
We've seen how knowledge distillation, dimension reduction,
Yeah.
and visual encoding are changing the landscape of AI.
And we've only just scratched the surface.
Right.
This field is moving so fast.
Yeah.
There's so much more to discover.
But before we wrap up this part of our deep dive,
Yeah.
let's take a moment to appreciate how far we've come.
Okay.
We've gone from bulky, resource-intensive models
Yeah.
to sleek, efficient ones that can run on your smartphone.
It's an incredible time to be following this field.
Right.
I can't wait to see what breakthroughs come next.
Welcome back to our deep dive into efficient text embedding models. We've seen how these, compact powerhouses are changing the game in AI, but their rise also kind of makes you wonder about the nature of intelligence itself, right?
Yeah, it's one of the things that makes this field so fascinating. It's not just about building better tools. It's about understanding how learning and knowledge work at a fundamental level.
We've talked about how these models are trained
Right.
using things like knowledge distillation and dimension reduction, but what does that tell us about intelligence itself?
It suggests that intelligence might not be just about raw processing power
Okay.
or the size of a neural network.
Yeah.
It could be more about how efficiently knowledge is transferred
Right.
and how well you can grasp the essence of complex information.
So it's not just what you know,
Right.
but how you learn and adapt.
Exactly.
Yeah.
And that's something these efficient models are really good at.
Right.
They're achieving similar results to their larger counterparts.
Yeah.
But using far fewer resources.
That really challenges our assumptions about intelligence, doesn't it?
It does.
Maybe efficiency and adaptability are more important than sheer size and complexity,
And then there's the whole idea of self-distillation.
right?
If models can learn from themselves,
Right.
constantly refining their own understanding,
Yeah.
could that be a key to unlocking even higher levels of intelligence?
That's a pretty mind-blowing concept.
It is.
Imagine a model that's not only learning from external data,
Right.
but also from its own internal processes.
Yeah.
It's like the AI equivalent of introspection.
It is like a form of introspection.
And if models can introspect in this way,
Yeah.
what does that mean for their potential for self-awareness?
Right. These are big questions we're only starting to explore.
It's exciting
Yeah.
and a little bit daunting at the same time.
It is a little bit of both.
We're entering uncharted territory where the lines between artificial and natural intelligence
Yes.
are becoming blurred.
Yeah, the boundaries are getting fuzzy.
But that's what makes this journey so compelling.
It is.
We're not just building machines, we're expanding our understanding of what it means to be intelligent.
I think that's a great way to put it.
So as we wrap up our deep dive into the world of efficient text embedding models, I want to leave you with one final thought.
Okay, I'm all ears.
If these models can learn from themselves and constantly evolve, what does that tell us about the limits of intelligence? Are there any boundaries? Or is intelligence like an endless capacity for growth and adaptation?
That's a question for each of us to ponder as we continue to explore this amazing world of AI. And as these models keep evolving, who knows what new insights they'll reveal about the very nature of intelligence itself.
It's been a fascinating journey exploring the cutting edge of AI with you today. We hope you've enjoyed this deep dive.
The pleasure was all mine. And remember, the quest for knowledge never truly ends. There's always more to learn and more to discover. So stay curious and keep diving deep.